We are now looking into total or equivalent resistance. And we have two types of circuits here. We have series and parallel, and the way we calculate them are different. So first, when we have series here, so our total here, okay, is going to be the equivalent resistance, and series is very easy. All we're going to do is add them up. So we just have 820 plus 1.2 kilo, which is the same as 1,200 ohms, and 150. So that one's good and easy. We're just going to add them up. 820 plus 1200 plus 150, and you get 2170. So that's going to be ohms. So our R total for this one is just going to be 2170. All right, now parallel is different. Parallel, you don't just add up. Parallel, the more resistors you add in parallel, the total or equivalent resistance actually goes down. Okay, so you need to remember that. We can't just add them up. And the equation we have is 1 over R total is equal to 1 over R1 plus 1 over R2, and so on and so forth. Okay, so let's start it off. So my 1 over R total is going to be equal to 1 over 5.6 kilo, which is going to be 1 over 5,600, plus 1 over 680, plus 100, or 1 over 8,200. Again, realize that it's not our total is equal to that. The answer is not adding those fractions together. The answer is adding those fractions together and then flipping it back over. Now, you could do all this fun fraction math, which I'm sure you'd love to do, but you don't need to. You don't need to worry about getting common denominator or any of that junk because you have a calculator and a good calculator. So you don't need to do all that. If I have to get this flipped over, what I can do is I can just add these fractions together, right? I can just take these fractions, write them as fractions in my calculator, okay? And then if I take those and flip it, it gets me 1 over this answer. So really what I can do is this. R total is going to be equal to that fraction I have, okay, to the -1. So all you have to do is add those fractions together in your calculator and do it in parentheses and then close the parentheses and say to the -1, and you'll get your answer. So the way it would look in your calculator is you'd have your first fraction, 1 divided by 5,600 plus, all right, and be careful, I don't need too many parentheses here. I just need that first set of parentheses to start off this that I'm going to flip upside down later, plus my 1 over 680, okay, plus my 1 over 8,200, whoops, 8,200, and then I'm just going to hit to the -1, which should be, sometimes your TIs will have it, but it's just going to be, you might see like an x -1 on your calculator, something along those lines, but I'll just say to the -1 here. So I type them in. I have my 1 divided by, so 1 divided by 5,600 plus 1 divided by 680 plus 1 divided by 8,200. Close my parentheses, to the -1, and I get a total resistance, equivalent resistance, of 564.6 ohms. Now, does that make sense? I added 5,600, 680, and 8,200, and I get only 560? Yeah, because again, what we talked about with parallel circuits, when you add more and more things in parallel, you get a much lower total or equivalent resistance.